In our previous lessons, we set up our workshop. The fundamental question is, what really is a variable? Many introductory courses explain a variable as a box where you store data. Well, this is a simple starting point. It is an incomplete and often misleading analogy. In this academic course, we are going to learn the truth about how professional programmers think about variables. In this lesson, we are talking about variables as being labels rather than boxes. Today, we are going to explore that idea with a much more powerful and precise analogy: a library. Think of a library on a city street with a very popular section. The temporary display shelves. The space here is limited and it's open for anyone to put a book on display for a short amount of time. Because it's so popular, shelves are constantly being filled and cleared. Think of your computer's memory as a massive, well organized library. Let's explore this with a scenario. Imagine you have a specific, unique book, the novel Hamlet by William Shakespeare. This book represents our data. You take this book to the library. On the cover, you place a sticky note with the label X. You hand this book to the librarian. The librarian sees the book Hamlet. The librarian first checks their records. Once they confirm that no book is currently labeled X and that there isn't already a copy of Hamlet on the shelves, they proceed, finds the perfect spot for it on the shelves. Let's say shelf number 28 and places it there. Then the librarian takes out their master ledger and makes a note. Shelf 28 is where the book labeled X is. Now think about it. Later, when you go to the librarian and ask for the book X, what do they give you? They give you the book Hamlet that is sitting on shelf 28. Imagine the PVM sees this line of code, X equal to 10. Here is the optimized logical sequence of events. Step 1. Check the namespace for the name. The first thing the PVM does is check its namespace table. It asks, does a variable with the name X already exist? In this case, it's the first time you are using X, so the answer is no. The PVM keeps this in mind. Step 2. Check the object store for the value. This is a crucial optimization step. Before creating a new object, the PVM checks its object store. We can say the shelf list. It asks, do I already have an object with the value 10 stored anywhere in memory? Let's assume this is the first time you are using the number 10. The answer is no. Step 3. Create the object and update the object store. Because the value 10 doesn't exist in memory, the PVM now reserves a new space in memory for it. It then updates the object store, mapping the new memory address to the new value. For example, 28 now holds the value 10. Step 4. Update the namespace to create the link. Finally, the PVM goes back to the namespace table and creates the link. It adds a new entry that maps our new variable name X to the memory address where the new object is stored. The name X now points to the memory address 28. Scenario number 2. A little while later, you go back to the librarian. You don't bring a new book this time. Instead, you give them a simple instruction. From now on, when I ask for the book Y, I want you to give me the same book you give me when I ask for X. The librarian, being very efficient, doesn't get a new copy of the book. They simply take out their ledger, find the entry for shelf 28, and add the new label. The ledger now looks like this. Shelf 28 is where the book labeled X and Y is. So after this, when you ask the librarian for Y, which book do they give you? The exact same single copy of Hamlet from shelf 28. Now let's look at the technical process inside the PVM. It's just as simple. When the PVM sees the line y equal to x, it follows these steps. It looks at the right-hand side of the equal sign first, which is x. It checks the namespace table to find out where x points. It finds that x points to the memory address 28. Crucially, it does not create a new object since we didn't provide a new value. It then looks the left-hand side y. It simply adds a new entry for y to the namespace table, pointing it to the same existing address. Okay, now let's test the exact same logic we saw in the library, but on our computers. Our first command to the PVM is x equal 10. Now we tell the PVM, please give me x. Print x. Notice it gives us back the number 10. Next, let's ask the PVM a different question. Please tell us where is the number 10 stored. Print ID x. The PVM tells us it's at this specific address in memory. This time, we tell the PVM y equal x. Then we ask, please give me y. Print y. Again, it gives us the number 10. Next, we ask, tell us where is y stored. Print ID y. Observe and think. It gave us the exact same address as x. This proves that the PVM didn't create anything new. It simply attached a new label to the same old location. Scenario number 3. Now for the most interesting part. You leave the library and come back with another copy of the exact same book, Hamlet by Shakespeare. This time you have put a sticky note on it with the label B. You hand it to the librarian. The librarian looks at the book and thinks, wait, I already have a copy of this exact book on shelf 28. It would be a waste of space and confusing to have two identical books in different places. This is how Python optimizes memory. It knows that the data already exists. So the librarian takes your new book, puts it aside because it's not needed, and simply updates the ledger for shelf 28 again. Shelf 28 is where the book labeled X, Y, and B is. Finally, we tell the PVM B equal 10. We ask, please give me B. Print B. Then we ask, tell us where is B stored. Print ID B. Again, observe and think. It is the same address as X and Y. This shows the intelligence of the PVM. It saw that the number 10 already existed in memory. So it didn't waste new space. It just attached the new label to the same existing location. Switch to more technical explanation. This is a beautiful analogy for what happens inside your computer. But who is this librarian? In our introduction lesson, I mentioned that Python is a high-level language, and you don't need to worry about things like memory management. That's because Python has its own librarian working behind the scenes. This system is called the PVM, Python Virtual Machine. The PVM manages two main ledgers, or we can say tables.